logs. Solve this problem. What should I do to solve for x?
Log 10.
Okay, it is a log base 10, but I got to get rid of this log.
That's what they're saying.
Not multiply by 10. I don't want to multiply.
Raised to 10.
Raised by 10.
Can we just square root it?
Oh, no, because it's inside. Okay, x squared is equal to 10 squared. What's the answer? What do I do next? Square root, yeah. And then x is equal to? Plus minus 10. Okay, the log problems are a little bit tricky. You have to plug it back in to double check, or really just kind of ask yourself, what's the domain? What's the domain of log x squared?
0 to infinity.
Everything except
0.
0. Everything except 0. So negative is okay because you're going to square it anyways. All right, okay. All right, I will send you the notes on this last one. Okay, these log equations are a little bit tricky because you have to check the domain. Okay, log x squared equals 2. All right, so we didn't finish this yesterday. What's the domain on this log x squared? Except 0 cannot equal 0. Okay, so whatever we solve, it cannot be 0. Okay, so we did this yesterday. We said log x squared is equal to 2. And then we raised both sides by 10, and we got x squared is equal to 100, and then we square root it. We said the answer is plus minus 10. Okay, so does both plus minus 10 work? Yes, because we just said the domain is just not 0. Right, so any number you get that's not 0 is good. Okay, I'm going to show you the wrong way to do this problem. Okay, so again, this problem is log x squared equals 2. Okay, you could bring this 2 down. If you do that, what would you do next? Divide by 2. And then what? Raised by, not log. 10, x equals 10. So you see what happened to...
You don't have the negative.
I don't have the negative 10 anymore. Why is that? I don't know.
Oh, because you get rid
Huh?
of the...
This 10 to the first is just 10.
Yeah, 10 to the first is just 10. But basically what happened was I changed the equation, right?
Oh, because you get rid of the square.
I got rid of the square. So when it's a square, technically it means there are 2 results, right? There are 2 answers that will work. When I got rid of it and I only got an x, that means only 1 result. So basically I reduced I changed the question. I changed the question so that there's only 1 answer, which is not correct. So you could do, you can, kind of do that in between to find the answer, but then you cannot just reduce the amount of answer to just 1. Okay, let's try another one. This is pretty tricky. Okay, again, natural log. Show me with your arms. How does natural log look like? Okay, Wimble's got it. Everybody's looking at Wimble for a model. Okay, so everybody show me natural log. Like this, right? So from the bottom up. Okay, so what's the domain on natural log? Silence. Huh? Greater than 0. Okay, so that means this entire thing is the domain part. It has to be greater than 0. All of this has to be greater than 0. All right. So, okay, remember we talked about this in chapter 2 maybe? We said that, let's say as a class, we're going to all go out to eat. Yay. And then some of us said we can only eat meat. Some of us says I only want to eat vegetables. Oh, okay, that would be kind of bad. And some people said I'm not really hungry. I'm just gonna drink some juice. So you have to find a restaurant that has all of them together, right? Right, so you go with the pickiest one.
Or just give up eating the zero.
Now we know how to be Daniel's friend. Don't be too picky. Okay, so what we're doing is we are adding these three functions together by combining, or basically combining means add and subtract, multiply and divide. So we have to look at what they all have in common, like who is the pickiest. Okay, so let's solve this. 3x minus 2 greater than 0. X minus 1 greater than 0. X greater than 0. So then we want to solve for the domain. Okay, so we're trying to figure out which of these natural logs I'm adding together is the pickiest one.
X greater than 1.
Okay, you guys are a little fast. Let me solve these. Okay, so we have x greater than 2/3, x greater than 1, x greater than 0. Right, so the pickiest one is x greater than 1. Okay, so it goes from 0, 2/3, 1. So 1 is the pickiest one. So that means our domain is x greater than 1. That means when I solve this question, Daniel, are you with us?
Yes.
You're just smiling at your iPad. Usually that's just
He's happy we're learning that.
Ah, that must be it. Thank you, Elizabeth. Okay, so whatever answer we get, we have to pick the one that's greater than 1. All right, so let's solve this problem. Well, we have 3 logs, and we have all x's stuck inside. Any thoughts about how to solve this? Raised by e?
E, that's what I meant.
And then distribute that e to everything?
Uh-huh.
Oh, no.
No?
You
Okay.
cannot do that. Cannot distribute that kind of stuff.
Do you have to
We
do
gotta somehow get only one log there.
multiply and dividing thing?
Yeah,
Like
so kind of, yeah, log rule,
Yeah.
like what we did on the warm-up. Okay, so we have a add first and then a divide. Oh, but before we divide, there's that 2 in the front. What should we do? Yeah, change that to a square. Okay, so this is going to be natural log 3x minus 2 times x minus 1 over x squared. And make sure you write equals 0.
What do you have to do?
Now, what?
You have to FOIL.
Yes, we do have to FOIL, but before that, what should we do?
Have, like, a new domain for
Now
X.
we could raise it.
Yeah, now we can raise it by e. Yeah, but we don't have to check the domain again because
Because
we already checked it. We already checked it from the beginning. Remember, we always only check the original one,
Oh.
not the one you started changing. Okay, so e to the whole thing, that's gone. 3x minus 2 times x minus 1 over x squared is equal to 1. Okay, now what?
Like multiply X squared.
Okay, so multiply by x squared and then FOIL. 3x minus 2 times x minus 1 equals x squared, and then FOIL. 3x squared minus 3x minus 2x plus 2 equals x squared. 3x squared minus 5x plus 2 equals x squared. Okay, now what?
Two.
Move the X to the left side.
X squared to the left side. 2x squared minus 5x plus 2 equals 0. Okay, hold on. I think only 3 people are answering my questions. Wait. Okay. Besides Daniel, Elizabeth, and Cami, what should we do next? Quadratic formula. Yes, quadratic formula works, and this one is a little bit easier. It does factor, so if it factors, factor. If it doesn't factor, quadratic formula. Okay, go ahead and find out what x is equal to. All right, 2x minus 1 x minus 2. So the answer is x equals 1/2 or 2. But domain says
Not 1. Or sorry.
greater than 1. Greater than 1. So only 2 works. All right, let's have you try one. Do the next one yourself and let me know when you have the answer. Okay, so combine it together. Log x minus 2 x plus 5 is equal to, we're going to have to get rid of that log, so we got to raise that 3 by 2. Okay, so now we can raise both sides by 10. Oh, I think a lot of you did it another way. You moved the log to the other side. That works too. How many people actually did it that way? Like you made it equal to 0 first? Okay, how many people did it my way, like this?
Kind of.
Okay, all right, so I'll just continue doing this. Okay, so this is gone. And then we can FOIL this x squared plus 3x minus 10 is equal to 9. And subtract 9 on both sides. X squared plus 3x minus 19 is equal to 0. So negative b plus or minus square root of b squared minus 4ac all over 2a. Negative 3 plus or minus square root of 9 plus, I don't remember the number, 85? No.
It's 76, so it's equal.
76.
Yeah.
Okay. And so negative 3 plus or minus square root of 85 over 2. Now what we want to do is look at a domain. So this one says x is greater than 2. This one says x is greater than negative 5. Kind of check all the answers. We get 3.11 or negative 6.11. So 3.11 is the only answer that works. All right, good. Okay, we're going to do the last section, which is very easy. It's called order of magnitude. How many people have heard of the word order of magnitude? Nobody. Oh. Like you guys watch like TV shows and then they say like, wow, the magnitude of this, or like the order of magnitude of this event is very big. No, okay, all right, just me. All right, so what order of magnitude means is, Bruno, are you with us? Hey.
Oh, yeah.
Okay. So basically what order of magnitude means is that how big is this compared to the other one, but not in the linear way. It's usually by the tenths, so 10 to the what power kind of thing. Okay, so first question, how many orders of magnitude? Okay, so make sure you read the question. Sometimes they will say how many times, and sometimes they say how many orders of magnitude. They're not asking the same thing. Okay, orders of magnitude. Is a kilometer then a meter? Well, let's look at 1 kilometer. 1 kilometer is how many meters? 1,000. And then 1 meter is 1 meter. So we wanted to get them to both have a base of 10. So 1,000 is the same as 10 to what power? Third. So that is 10 to the third meter. And we can put a 1 in front of it, make it look like scientific notation, right? 1 meter is the same as 1 times 10 to the what power? 0. So the question is, how many orders of magnitude is it bigger? So basically, we compare the exponents, and 3 minus 0, so it's 3 orders of magnitude bigger. So 3 orders of magnitude actually means 1,000 times bigger. Okay? So order of magnitude is a little different from just how many times. It's how many 10 to that times. Okay, so let's have you practice $1 more than a penny, a horse weighing 400 kilograms, then a mouse weighing 40 grams. You have to always turn it into the same unit. Whatever the unit is, you have to turn it into the same and then compare them. Okay, let me know. Huh?
How many pennies are worth
100. 100. Good question. Like, every year I was just like, oh, penny. And then people are asking, is this the same as cent? And then nickel is the same thing. People always ask me, what's a nickel? Yeah, so it's okay. That happened to me when I first came as well. All right, let me know when you have 1 and 2 then. Okay, $1 more than a penny, so $1 is 100 pennies. So that is 1 times 10 to the second. 1 penny is just 1 times 10 to the 0. So that is 2 orders of magnitude. A horse weighing 400 kilogram. Okay, so that is 400 times 1,000 gram. So that is 4 times 10 to the 5th. And the mouse weighs 40 grams. So that is 4 times 10 to the 1st. So 5 minus 1 is going to be 4. So 4 orders of magnitude. The last one is population of 8 million. 8 million means, or a million means 6 zeros. So that is 8 times 10 to the 6th. 8 people is just 8 times 10 to the 0. So that's 6 orders of magnitude. Pretty easy, right? Okay. Next one. Earthquakes. So we're going to apply orders of magnitude to earthquakes. It says, how many times more severe was the 2001 earthquake at this place in India? And R1 means Richter scale. Do you guys know what Richter scale means?
Mm-hmm.
Like the level of earthquake.
Yeah, the order of magnitude of earthquake. So this place had a Richter scale of 7.9. And they said, how much more severe is this one than the 1999 earthquake in Athens, which is 5.9? Yeah, so I don't know if your teachers has ever mentioned this to you, but in 8th grade, I had a science teacher who told us that Richter scale is not linear. So somewhere that had a 5.9 and somewhere else that has a 7.9 is not linear. It's not just a little bit bigger. It's a lot worse. Okay, so we're gonna see how much worse. The problem is Richter scale is not linear. It's order of magnitude. That's why it is the way it is. Okay, so how many times? So basically, they're not asking order of magnitude. They're asking actually how many times is it worse. So that means A1 over A2. So we want to figure out what is A1 over A2. A is the amplitude, so how much the earthquake is shaking the earth. And these other two variables are, they're not really variables, they are constants. And then this is how Richter scale is done. It's log A over T plus B. You don't have to memorize this formula. It's just kind of showing you how order of magnitude is used. Okay, so we want to find A1 divided by A2. So we're going to start with R1 minus R2. R1 minus R2 is 7.9 minus 5.9, so that's going to be 2. Which is the same as log A1 over T plus B. That's R1, right? I just replaced R1 with that equation. Except in that equation, I specify A1 because that's for the first place. Minus log of A2 over T plus B. Sorry, this is so messy. Okay, now I am going to simplify this. Log of A1 over T plus B minus log of A2 over T minus B. I distributed a negative.
Oh, okay. So T was gone.
No, B is going to be gone. B is gone. So now I have 2 equals log of A1 over T minus log of A2 over T. Okay, I need to figure out what A1 over A2 is. So I'm going to combine the logs together. So it's a minus, which means divide. Log of A1 over T over A2 over T. Okay, this is the same as log of A1 over T times T over A2. The T's are going to cancel. So you can see that log of A1 over A2 is equal to 2. Okay, now how do I solve for A1 over A2?
We put raised to the 10.
Raised by 10, yes. 100 equals A1 over A2. So the question is, how much worse was the India earthquake than the Greece earthquake? 100 times. Yeah, it's so when you next time you see on the news about some earthquake, remember to yourself, this is not just linear. Oh, it's just a little bit worse. It's that order of magnitude worse. So I'm going to tell you a trick. The Richter scale, so R2, sorry, that was R1. R1 minus R2 was 7.9 minus 5.9, which is 2. So that is 2 orders of magnitude worse, which means 10 to the second. It's basically the,
So it's just like.
yeah,
Wow.
yeah,
First.
yeah, it's just kind of working through an equation.
Why didn't you show?
The easy way?
Yeah.
Then you lost the beauty of a
No,
formula.
So the whole time.
All right. Okay. There's another question for chemistry application, but every time I say chemistry application, everyone says, oh. So I'm going to skip that, but I'll let you guys start on homework right now. So you have like almost 10 minutes to do homework.